So you had a question regarding all of these molecules that was asking you which of the three reactions favors the acetal form at equilibrium and which of the three reactions favors the carbonyl form at equilibrium. I first want to go over what the acetal versus carbonyl form means. So the acetal form is basically your molecule where what used to be your carbonyl carbon is now attached to two OR groups, which OR groups are basically just oxygens attached to any R group or any carbon group. So all of these molecules on the left here are your acetal form. The carbonyl form, on the other hand, is when you basically just have a carbonyl, which a carbonyl is a carbon double bonded to an oxygen. So all these molecules that I've drawn on the right, which were our products, these are all the carbonyl form. So your question was asking which of the reactions favor the acetal form at equilibrium and which favors the carbonyl form. What we have to keep in mind is that equilibrium just means that all our reactions can go towards either direction. The acetal and carbonyl forms can be interconverted just by using H plus and H2O. So all these reactions here exist in an equilibrium. So it's not necessarily just a one-sided arrow, but they exist in equilibrium. They can go in the reverse direction as well. So our question is basically asking us which side of the reaction is favored, the acetal form or the carbonyl form. So in order to answer this question, what you basically have to keep in mind is that the more stable your carbonyl form is, the less reactive it's going to be, and the less willing it's going to be to convert to the acetal form. So when we're determining carbonyl stability, what you have to keep in mind is that our carbonyl carbon is attached to an electronegative oxygen. So if we're looking at the dipole of this bond, oxygen has a partial negative charge because it's more electronegative, and this carbonyl carbon has a partial positive charge. So basically what we're looking at, we want to stabilize this partial positive charge here. The more stable that partial positive is, the less willing a nucleophile is going to be to come attack this carbonyl carbon and convert us from the carbonyl form to the acetal form. So the more stable this molecule is, the less reactive it's going to be. If it was less stable, it would be more willing to turn into something else, so it would be more reactive. So electron donating substituents will actually stabilize our partial positive charge, and examples of electron donating substituents are just carbon groups because they will push electrons towards this positive charge, making it less positive, therefore more stable, because more neutral charges in general are more stable. On the other hand, electron withdrawing substituents will destabilize our positive charge because they will actually pull away electrons from this partial positive carbon. So if we're pulling away electrons, which are negatively charged, we are making this partial positive even more positive than it already is and less stable. So electron withdrawing substituents would be more electronegative elements like oxygen or fluorine or something like that. So if we look at an example of favoring carbonyl versus acetal form, you can see that the more carbon groups that I have attached to my carbonyl carbon, the carbonyl form is favored, versus here I have less carbon groups attached to our carbonyl carbon and more electronegative elements like fluorine. So this is going to have a less stable partial positive carbon and it'll favor the acetal form. So let's take a look at our three molecules. So we've kept in mind that if we have more carbon groups attached, that is going to stabilize our partial positive carbon and make the carbonyl form more stable. Therefore, this will be less reactive. So if we look at the bottom molecule right here, it's attached to two carbons. If we look at the middle molecule, it's attached to one carbon, and the top molecule is also attached to one carbon. Since this molecule is attached to the most carbons, the carbonyl form of this molecule is going to be favored at equilibrium. So this one will be our reaction that favors the carbonyl form at equilibrium. So now we need to look at these two molecules here. Which one will favor the acetal form at equilibrium? So we've talked about how if we have electronegative substituents attached, this will pull away electrons from our carbonyl carbon, making it more positive, less stable, and therefore more willing to react and convert to the acetal form. So if we're comparing these two molecules, this molecule has one alcohol molecule, which oxygens are electronegative, so one alcohol molecule pulling away electrons from this partial positive charge, destabilizing it. On the other hand, this molecule has two alcohols pulling away electrons from our partial positive charge, making this partial positive more positive than it already is, less stable, and therefore more reactive. So since we have more electronegative groups on this molecule than we do on this molecule, this carbonyl is the least stable, so this will be the most reactive towards converting to the acetal form. So this molecule will favor the acetal form at equilibrium.